Hello, Sec 5. We are going through 2017 Media Exam Paper 2, question number 10, the last question. This is a question about real-world problems. I know this question is a little bit difficult because it involves volume, which you are not very familiar with. But let's take a look at how we do this question, all right? Now, here is some information about vertical cement silo. Now, this is a silo to put cement inside before they harden, all right? Now, the safe volume is 62.3 meters cubed, and the safe volume, you can only fill that to 90% of the silo. So which means this 62.3 meters cubed is 90%. Now, in part A, they ask you to calculate in volume the cubic meters of the entire cement silo, which means 90% is 62.3 meters cubed. You want to find 100%. To find 100%, all you need to do is take 62.3 divided by 90 to find 1%, and then times 100. So it's just 62.3 over 90 times 100, and you will get, you must write in fraction because it's more accurate, 69 2/3 meters cubed. Okay, that's the entire volume of the cement silo. Let's take a look. They said the cement silo can be modeled as a cylinder with a cone at the bottom. It is given that the height of the cylinder is 2.5 times the diameter and the total height of the silo is thrice the diameter d. Basically, they give you all the dimensions and they ask you to find the value of d. So basically what they want you to do is they want you to equate the volume of this equals to 69 2/3 meters cubed. You see? Now, this is very simple because it's made up of a cylinder and a cone. So let's split it up. A cylinder plus a cone, the volume of the cone will give you 69 2/3 meters cubed. Now let's try to fill in the dimensions. This is D. This height of the cylinder is 2.5 D. Now, what is the height of the cone? Is actually 0.5 D. And the diameter of the cone is, of course, D. Now, if you remember the formula of the cylinder, it is actually pi r square h, which is pi r is half of the diameter, pi r square h, 2.5 D, plus the cylinder is 1/3 pi r square h. Equate it to 69 2/3. Alright. Now if you press your calculator, of course when you press your calculator you don't press the pi, you just press a half square times 2.5. So it's half square times 2.5. You get 0.625 0.625 pi d cubed. Now why is it d cubed? It's because this is d square times d will give you d cubed. Alright, let's continue. Plus, now what do you press in your calculator? You press 1/3 times half square times 0.5. 1/3 times half square times 0.5. That would give you 1/24. 1/24. So it's 1/24 pi d cubed. Now why is it d cubed? Same. D square times d is d cubed equals to 69 2/3. Now from here you will realize that both are pi d cubed. Okay, both are pi d cubed. This is pi d cubed and this is pi d cubed. So I can join the fraction together. So on my calculator, I press 0.625 plus 1/24. Then I'll get 2/3. So this is 2/3 pi d cubed equals to 69 2/3. Now I want d. So I must divide by 2/3 pi. So d cubed is 69 2/3 divided by 2/3 pi. That will give me d cubed. So I need to press my calculator. 69 2/3 divided by 2/3 pi. That would give me 33.26338. To get D, I cube root this 33.26338. So I need to cube root the answer, and I get D is 3.2160. To three significant figures is 3.22 cm. Now I know the answer sheet is a little bit different, but it's okay because we are using the more accurate answer of 69 2/3 instead of 69.222. If you are not sure about this question, you can pause the video right here and then after that figure out what's happening. Alright, most importantly, volume of a cylinder is pi r square h. The cone is 1/3 pi r square h. Always remember that. Part C. Now they say given that the density of the cement it's a range from 1440 to 1506 kilogram per meter cube. The silo is initially empty. He wants to fill the silo with 96,000 kg of cement, but I don't know whether it will fit in or not. Right? So you need to find the volume. Now, if you remember in your physics, mass, density, volume. In order to find the volume, I need to take mass, which is your 96,000 divided by the density. I don't know the density. The density from the lowest is 1440. The highest density is 1506. Now, if I'm given two densities, what I need to do is I need to divide by both densities to find out the volume in between. So therefore, volume, if the density is 1440, is this. So V equals to 96,000 divided by 1440. The possible volume would be 96,000 divided by 1440 is 66 2/3. 66 2/3 meters cube. Then if the volume, if D is equals to, if the density is 1506, see what happens to the volume. 96,000 divided by 1506 divided by 1506, that would give me 63,187 over 251 meter cube. So the volume lies between 66 2/3 and 63,187 over 251. So it's possible. So now, if you read the question, it says, comment on whether this is possible and whether it is advisable. So there are two questions here. Is it possible and is it advisable? Now let's take a look at our volume at the beginning. Now our volume at the beginning states that the silo can hold up to 69 2/3. But if you look at these two numbers are below 69 2/3. So is it possible? It's possible. But is it safe? So now let's take a look. The safe volume is 62.3. 62.3. You see, even if the density is the highest, the volume is still 63 more than your 62.3. So therefore, it is possible to put the cement in the silo, but it is not advisable. Now, they want you to justify your comment with calculations. So you need to explain even more, because the volume is between 63,187 over 251 and 66 2/3, because it is possible to put it in the silo of volume 69 2/3 meters cubed. But because the safe volume is 62.3 meters cubed, it is not advisable. Alright, so you need to explain your answers. Now, part 2. To fill up the silo, cement is pumped using a cylindrical pipe. He wants to fill up the silo in the shortest time, and he has two options. Option A, he wants to use a cylindrical pipe with diameter 30 cm. B, he wants to use two smaller cylindrical pipes, and each of them is 20 cm. Now, he chose option B. Do you agree with him? You see, in order for the cement to flow quicker into the silo, this area must be bigger. So all we just need to do is to compare this area, the area of the two circles. We see whether the area of the two circles is bigger than the area of the one big circle. It's very easy to calculate. So area of circle is pi r square, which is 900 pi. This area is 2 times of pi, radius is 15. I made a mistake. R square. So 15 square is 225. 225 pi. 2 pi r, which is 10 square. 10 square is 100, so it's 200. Total is 200 pi cm square. Now, if you see, this is smaller, has a smaller area than this. So, of course, we don't agree with him. So, I will write, I don't agree. Explain, because the cross-sectional area of pipe A, of option A, is bigger than the cross-sectional area of option B. Okay, that is the problem for real-world context that you would encounter in your O-levels. I know this question is a little bit difficult, but get used to this difficulty of the question, alright? You can do it. Okay, that's all I have for you today. Please do 2018 questions 1 to 5. Post your corrections up and the new questions up onto OneNote for me to take a look. Okay, that's all. Thank you.